Okay, our graphing segment continues, and we are going to now, I'm now going to show you how to finding equations, finding the equation of a line. Let's see what that looks like. So notice I'm not graphing yet. I'm looking at all the questions that you can see when it comes to when you do algebra at the college level or at high school or middle school, I'm not sure. But basically, the first video shows you how to plot. Then there's a video on how you find the slope. The slope is represented by m using the formula y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. This is finding the slope, and then finding the x and y intercepts, which I showed you that whenever you have the x and y coordinate for your x intercept, your y would be 0 and your x will have some type of value, and for your y intercept, x will be 0, and so let's say a0, and y will be some type of value, which you see in previous videos how to find your x and y intercepts. Now we're going to be finding the equation of a line, and usually that is done in two cases. Two cases will be given. And the first case is that you will be given a slope m and a point x1, y1. And what's beautiful about this, again, if you have to commit to memory a formula. So there's a formula where you will substitute your given value of m and x1, y1. And that formula is called the point slope formula. The point slope formula, which makes sense because you're given a point and a slope. So what that formula looks like, it will be y minus y1 equals to m times x minus x1. So here you'll just plug in values for your x1, y1, which is given here, and your m, right? And then you'll solve for y so that you'll develop this equation that looks like y equal mx plus b. Basically, this is how an equation of the line usually supposed to be in this form. I call it the main man, because there are about two forms. There's a general form, which we spoke about in previous videos, but all your equation of the line need to come and look in the form where y is your line and it's equal to the slope times a constant x plus b, which we found out earlier. B is your y-intercept when x is 0. And this is called the slope-intercept form, as I pointed out earlier. So this is the first case in which you will be asked to find the equation of the line. You will be given a slope and a point. Let's see what that looks like by example. So for example, it'll say find equation of the line, and I'm just saying it, I'm not going to write it, given the slope equals 2 and a point equals negative 1, 3, right? So here I have my m, and here I have my point x1, y1, and then I just have to commit to memory my point slope formula. So I'm going to substitute my values that are given. So my values are, my y1 is 3, my m is 2, and my x1 is negative 1. Watch out for signs. Remember, this is not minus 1 because this minus 1 doesn't take care of the minus in the formula. It's minus x1, and x1 is minus 1. So now I'm going to solve for y, so I can get it in the form of the main man or into my slope-intercept form. So this is plus 1. Taking my time to do the steps, then I'm going to do distributive property, where I have my constant times a group of terms. And then I'm going to solve for y by subtracting the term negative 3, adding the term negative 3 to both sides. The opposite operation of subtraction is addition. Combine my like terms. So, of course, your equation game has to be tight also when learning to graph. So you got to commit to memory formula, and you still have to remember your rules of equation. So this is what happens. This is one case in where you find the equation of a line given a point and a slope. Now, case 2, you will be given 2 points. So you'll be given a P1, x1, y1, and a P2, x2, y2. Okay? And guess which formula you have to use? Yep, you still have to use the same point slope formula. You still have to use the same point slope formula. You're probably wondering, well, where is my m? Yes, where is your m? Don't say your m is not there. Your m is right there, but it requires some integrated knowledge, right? Hence, guess what? You got to find your m. So when given 2 points, you got to find your m using your formula, because you are given 2 points, so you can find the slope. I'm just going to use the y1, the difference between y1 and y2 formula. I showed you earlier that both works. And I'm going to find my m if in an example here. So let me give an example. Let's say I have -1, 2. I'm just going to keep simple numbers, and 2, -3. So these are my 2 points. That's my x1, y1, my x2, y2. And I'm just going to substitute my points into this formula. So my y1 is 2 minus my y2, which is -3. And my x1 is -1. And my x2 is 2. So let's see what my m is. That is 2 plus 3 over -3, which is 5 over -3. So it's -5/3. Didn't want to work with fractions, but not a problem. It's a reality. Fractions will show up in your problems. So now I have my m. So I can apply my point slope formula, and I have a point. Now mind you, I can use any 2 points. By default, I'll just use my first point, but I promise you, if you use the second point, it will yield the same answer because it's the same line. So here we go. I'm going to substitute. My y1 in this example is 2. My m is -5/3. And my x1 is -1. And now I'm going to solve for y. So let me take my time and do that. So here we go. -5/3. This is x plus 1. Distributive property. -5/3 x minus 5/3, because I distribute. Now I'm going to add 2 to both sides because I'm looking for y. -5/3 x. I'm going to find an LCM here to evaluate these two constants because they're like terms. So this is obviously 6 over 3, right? So it's -5 over 3 plus 6 over 3, which will give me a +1/3. And this is the equation of the line. Now for you possibly doubters, I'm going to try it using the second point to show you that I'll end up with the same answer. So let's find a nice little clean spot up here. And let's see what we got. So my slope is -5/3. That's not going to change. But what I'm doing is I'm using a different point to show you it doesn't matter which point I use, I will yield the same answer. Okay, so that's y minus. So in this case, I know it's y2, but it's the same. It's just saying I'm using one y. All right. So it's my y2 I'm using in this case. So that's -3. And my slope remains the same, x. And I'm using my x2 to show you that it's going to be the same. So minus x2, x2 is positive. So here we go. That's y plus 3 equals to -5/3 x minus 2. I'm going to distribute. And let's just cut to the chase, okay? I'm going to subtract the 3 in advance just for the sake of space. I'm going to distribute my 5/3 x plus, because that's 2 positive, that's 10 over 3 minus 3. I'm going to find an LCM so I could combine these like terms, which are constants. I can't combine the x because that's an x term, -5/3 x. So clearly here is 9 over 3, and 10 minus 9 is positive 1/3. Bam. So here we go, positive 1/3 when I use the first point, and 5/3 x plus 3 when I use the second point. All right, let's just do one more example. I noticed I did one more example. So finding the slope, not slope, finding the equation of a line given 2 points. So let's just pick a point, 0, 3, x1, y1, and the other point I'll pick is negative 1, 1, x2, y2. So of course, we're going to apply our formula, the point slope formula. And here we don't have our m, so we have to take an extra step when given a case 2 problem. Case 2 meaning given 2 points. We have to take an extra step. So I'm going to find my m. So let's start first with finding my m. So I'm going to set it up by default, y1 minus y2. So that's 3 minus 1 over x1 minus x2. And x2 is minus 1. So this is 4. I'm sorry. 3 minus 1 is 2. And this is over positive 1. So my slope is 2. Beautiful. Now I'm going to substitute my value. I'm just going to use the first point by default. We show that it doesn't matter which point. It yields the same answer. I'm just using my first point by default. My slope is 2 and my x1 is 0. Beautiful. So this is y minus 3 equals to just good old 2x because this will cancel. I'll add 3 to both sides. Ah, this is such a wonderful line. Nice linear function. Beautiful. All right, and then I'll do another problem with case 1. Case 1, I'll be given a point. Given a point up a slope. Let's try a half, just a half, because fractions are possible. And a 0.15. Okay, and here we could just cut straight to the chase. We don't have to take that extra step of finding the slope. So I'm just going to plug in with my formula. And my y1, label the points. I always advise students label the points is 5. My slope is a half, and my x1 is just good old 1. So this is y minus 5. I'm going to do distributive property, solving for y. Add 5 to both sides. Find an LCM. Obviously, it's 10. So if I'm looking at these two terms, my LCM is 10. So that's minus 1 plus 10 over 2. My LCM is 2. So my 5 is now 10 over 2, which is 9 over 2. No need to convert into a mix. I would leave it as an improper fraction. And this is my equation of the line. So there it goes, guys. How to find equation of the line given 2 cases. The first case is when you have 2 points. When you're given 2 points where you have to take an extra step and find the slope first before using the point slope formula to substitute the given values. Or the other case is when given a slope and a point and you just cut to the chase. You don't have to find a slope. You just plug it right into the point slope formula. And there you will find equation of the line. The next video will come down to graphing.